All right, last unit for this, or last video for this unit is the study guide. Just gonna go over some practice problems before I post your test. So this is just going over everything that we learned in this unit. So the first thing we learned was the fundamental counting principle. All right, remember that's when you have different possibilities of having things happening. That was the easiest one of finding out the possibilities of having stuff happen, because all you do is multiply whatever amount of events you have. All right, so for example number 1, we want to suppose that we create a 6-digit password, LLL, hash, or pound sign, whatever you want to call it, 3 times, where L represents every letter in the alphabet, but you cannot use vowels, and the hashtag represents 1 through 9. How many password possibilities are there? All right, so with our letters, we have every alphabet letter except for our vowels. Remember, that's A, E, I, O, and U. So that's out of 26 options, we have to take out 5 of them, which leaves us with 21. All right, so that means that 21 can happen 3 times. So 21 times 21 times 21. And then our numbers are from 1 to 9. So that's 9 different options there, times 9 times 9 times 9. All right, so all we have to do is do 21 times 21 times 21 times 9 times 9 times 9. And another way you can type that in your calculator is that 21 happens 3 times, so that's 21 to the 3rd times 9 to the 3rd. And it'll give you the same thing either way. So we have 6, 7, 5, 1, 2, 6, 9. So we have 6,751,269 possibilities to create our 6-digit password. Okay? Number 2 says Christian goes into an ice cream store where he can choose 3 flavors, chocolate, vanilla, or strawberry, 2 types of sprinkles, either rainbow or Oreo, and 2 types of toppings, either a cherry or whipped cream. How many possibilities does Christian have? All right, we got to take the flavors, so that's 3 flavors, times our sprinkles, which is 2, and then times our topping, which is another 2. So all you got to do is multiply all those together. So 3 times 2 gives me 12. So 12 different possibilities that Christian can have his ice cream. All right. Number 3 says, how many outfits are possible with 5 pairs of jeans, 8 t-shirts, and 2 pairs of shoes? So again, 5 pairs of jeans times 8 t-shirts times 2 pairs of shoes. So 5 times 8 is 40, times 2 is 80. So 80 different outfits can come out of that. All right. And that's assuming that everything matches, which we know that most times with girls, they don't match. With guys, y'all don't care if they match or not. All right, so then we talked about permutations. Remember, permutations is when order matters. Okay? And the way to write a permutation is you would have N, P, R. Okay? Sub N, P, sub R. And the equation for that was N factorial over N minus R factorial. All right, so like for example, we have Yummy Yum has prepared cupcakes with 5 different toppings: sprinkles, coconut, chocolate chip, Oreo crumbles, and M&Ms. And how many ways can they arrange 3 of the cupcakes in a display case? So remember, this is when order matters, because whether we have Oreos in front or Oreos at the end, it matters, okay? Because a lot of times when people do displays and stuff like that, you want to have the most appetizing first, because the people are going to automatically snatch that. Like, to me, Oreos are my favorite. So as soon as I see an Oreo cupcake, it's gone. That's my first thing I'm going for. All right, so we have 5 different ones, and we want to choose 3. So the way we would write that is 5 permutation 3. All right, and remember, I told you there was a couple of different ways to do this in your calculator or by hand. And so that's 5 factorial over 5 minus 3 factorial. So by hand, that would be 5 factorial over 2 factorial. And the way we would write that is, that becomes 5 times 4 times 3 times 2. And notice I have the 2 factorial on the bottom, so those would cancel out. So that just becomes 5 times 4 times 3, which is 60. All right, using our calculator, we could just type in the 5 factorial over 2 factorial by doing 5, hit math, go to probability, and go down to the factorial, divided by 2, math, and go down to factorial again, and that'll give us 60. Or you can type in 5, hit your math button, go over to probability, and you have that NPR option, and then type in 3, which will, again, give us 60. So there's 60 different ways that we can order 3 out of the 5 cupcakes. All right. Number 5 says, how many ways can a club select a president, vice president, and a secretary from a group of 5 people? So again, we have 5 people, and we want to choose president, vice president, and secretary. So that's 3. And again, here, order matters, because if I tell Alex that he's president, and then all of a sudden I change it and say that he's secretary, that matters, because there's a difference in between those 2 roles and their jobs and that type of thing. So that's going to be the same thing as what we got up here, which is 60. So without having to do all the work, you already know what the answer is going to be. All right, number 6 says, Sarah plays softball over the summer. If there are 10 players on the team, how many ways can the coach make a batting order that includes all of the players? So we have 10 players, and we want to choose 10 of them. So that becomes 10 factorial over 10 minus 10 factorial. And remember, we said 10 minus 10 is 0. 0 factorial is the same thing as 1. Okay, so that just becomes 10 factorial over 1. So 10, hit our math button, goes down to factorial. Or you can still do the 10 p 10, and it'll still give you the same answer. So we have 3,628,800 different possibilities to order our softball players. All right, and then number 7 is just showing you, making sure you know how to, again, do 7 permutation 2. So that would be 7 factorial over 7 minus 2 factorial. And again, mathematically by hand, that would be 7 factorial over 5 factorial. So that would become 7 times 6 times 5 factorial, which I see is on the bottom. So they would cancel each other out, which would just give us 7 times 6, which is 42. And again, you could do the calculator way. You could do 7 factorial divided by 5 factorial, or 7, hit that permutation button, and then hit 5, or 2, and then you would get 42 as well. All right, so that's the first page of our study guide. And then number 8 is another permutation problem. I just ran off to the next page. And we want to arrange the letters in the word Jalil, or the name Jalil. So we remember, that's when you take whatever letters are repeating and do a factorial on the bottom. So we have L happening twice and E happening twice. Okay, the total amount of letters is what goes on top. So we have 1, 2, 3, 4, 5, 6, 7. So that's 7 factorial over 2 factorial times 2 factorial. Okay, and remember, in your calculator, you need to put parentheses around the bottom. So that means we go 7, hit our math button, go to probability, and go down to our factorial, divided by parentheses, hit math again, go over to probability, hit factorial again. Oop, I forgot to hit the 2. Math factorial times 2 math factorial. And then close our parentheses, and that gives us 1,260 ways to arrange the letters in Jalil. All right, so then we move on to combinations. And remember, combinations, order doesn't matter. And remember, that's when we're talking about, like, say, we're talking about 3 people are going on a trip. Doesn't matter which way I say Bob, Billy, and Joe, but they're still going whether I say it Joe, Billy, Bob. Like, it doesn't matter, because they're all 3 going. Or if I say we're picking 5 people to take a survey, doesn't matter. Okay, they're still going. Or if we talk about the order of a trip, it doesn't matter as long as as long as the trip is the same amount of time for everyone. All right. So number 9 says we have 6 friends are going to play a ball game. Each team has 3 players. How many different team combinations are possible? Oh, and remember, the equation for combinations is n factorial over r factorial times n minus r factorial. Okay, so we have 6, and we want to choose 3. So that becomes 6 factorial over 3 factorial times 6 minus 3 factorial. Okay, and so that becomes 6 factorial over 3 factorial times 3 factorial. And you could type that in your calculator, or by hand you would do 6 times 5 times 4 times 3 factorial. And one of those 3 factorials on the bottom would cancel out. And then the other 3 factorial would still be left with 3 times 2 times 1. All right, and so you would just do 6 times 4 times, 6 times 5 times 4, and 3 times 2 is 6, so just divide by 6, and that gives us 20 different options. Okay, or you can do 6 math, go to our probability, and you have that NCR option again, and we want to choose 3, so that'll give us 20 again. So there's 20 different ways that we can order a team picking 3 boys. And again, this is why it doesn't matter, because it doesn't matter whether I say which 3 boys are going to play in the game, okay? As long as they're in the game, they're all still playing on the same team. It doesn't matter if I say Ajane, Alex, and Christian, or then I say Christian, Ajane, and Alex. They're still all 3 on the same team. All right? Number 10 says the number of 4 letters that can be chosen from the alphabet is. All right? So we have 26 letters in the alphabet, and we want to choose 4 of them. Okay? So again, you in your calculator, the equation will be 26 factorial over 4 factorial times 26 minus 4 factorial. And if you simplified that, that would be 26 factorial over 4 factorial times 26, 5, 4, 3, 2, 22 factorial. All right, and you would go in the calculator, 26 math factorial divided by 4 factorial times 22 factorial. And that gives us 14,950 different possibilities. Or you can just do 26 math, go to our NCR, and choose 4. And then that gives us the same answer. All right, and then the last one for our combinations is 9, choose 4. And just as an FYI on your test, you will need to know the difference between the two, because on the test there's going to be some questions that say, which one is this, a permutation or a combination? Okay, so we have 9 combination 4, so that's 9 factorial over 4 factorial times 9 minus 4 factorial. Okay, and just to do the quick calculator way, we hit 9, go to math, hit our probability, NCR, and then type in 4, and that gives us 126 combinations. All right, then we got into probability. It says, what's the probability of rolling an even number on a dice? Well, again, there's 6 different possibilities on a dice. We want the even numbers, which is 2, 4, and 6. So that's 3 out of 6. Now remember, I want your probability simplified. So 3 out of 6 simplifies to math, enter, 1/2. Okay? Same thing with number 13, says we want to know the probability of rolling a 1, 5, or 6. So that's 3 possibilities out of 6 total, which again simplifies down to 1/2. Okay? And then the last one says there are 12 boys and 6 girls. What's the probability of choosing a girl from the group? Well, there's 6 girls total out of 18, because 12 plus 6 is 18. And so that simplifies down to 1/3, and you can do that in your calculator. 6 out of 18, hit math, enter, and that's 1/3. Okay. And then we got into compound probability, which was where you had 2 different things happening and you multiply those probabilities together. So with number 15 says, what's the probability of flipping a coin and rolling a dice and getting a heads and a 2? So heads, there's only 1 out of 2 possibilities for that happening. And then rolling a dice, a 2, only 1 out of 6 times that that's going to happen. And so you just multiply across, so that becomes 1 out of 12. Okay? So that's your answer there. And you can't simplify 1 out of 12. If the top number is 1, there's no way to simplify it. All right? Number 16 says there's 3 red marbles, 2 blue marbles, and 4 white marbles. All right? You randomly select a marble, replace it and pick another marble. what is the probability of picking 2 blue marbles? Okay, so we're replacing it here. So that means I'm picking a blue marble. That is 2 out of 9 because there's 9 marbles total. Okay, and then you're picking another marble again, and again, we still want blue, so that's 2 out of 9. We replaced it. We put it back, so that means none of my totals have changed. And so 2 out of 9 becomes 4 out of 81. And then we just check to make sure see if we can simplify that or not. 4 out of 81, math, enter, enter, which is still 4 out of 81. All right, and then that's our final answer. Okay, then we go down to the next page. Okay, number 17, there are 3 red marbles, 2 blue marbles, and 4 white marbles. You randomly select a marble, do not replace it, and pick another marble. What's the probability of picking 2 blue marbles? So this is the same problem, except for this time we're not replacing that original marble. So we have 2 out of 9 possibilities to choose a blue marble the first time, but then the next time I have 1 blue marble missing. So that becomes 1 out of 8 because I didn't replace that marble. So that means my total went down as well. So that becomes 2 out of 72, which simplifies to 1 out of 36. So you have 1/36 chance to pick 2 blue marbles if you don't replace that first one. All right, number 18 says you roll 2 dice. What is the probability of rolling 2 even numbers? Okay, so what we're talking about is we want to roll a 2, a 4, or a 6 from both of them. Okay, so for the first dice, that means that's 3 out of 6 possibilities. And for the second dice, that's 3 out of 6 possibilities. So that becomes 9 out of 36. And we simplify that, 9 out of 36, math, enter, enter, which gives us 1/4. So you have 1/4 of a chance of rolling 2 even numbers, which isn't bad. All right. Then number 19 says you pick 3 cards from a deck. You do not replace them. What is the probability that they are all king, queen, or jack? So remember, you have 4 different suits. You have hearts, spades, diamonds, and clubs. So that's 4 different times you have a king, queen, or jack. So that means I have 12 different possibilities out of 52. Okay? But we're picking it out of 3 different cards. So that means that my first time I have 12 out of 52. But that means the next time I'm only going to have 11 out of 51 because that first one is taken out. Then the next one, my third card, is going to be 10 out of 50 because we picked 3 cards and we did not replace them. So that means my probability for each one loses 1 possibility out of each answer. Okay, so we multiply all those together. 12 out of 52 times 11 out of 51 times 10 out of 50. Which gives me math, enter, enter, 11 out of 1,105. So you do not have a very good probability of picking 3 face cards. All right, and then the last one in our probability says you roll 2 dice. What is the probability that you roll a sum of 8? So I'm just going to go back to our notes that we did with the sum just to look at the table because I don't feel like writing the table all the way out. If I go back here, the 8 happens 1, 2, 3, 4, 5 times out of 36 total. Okay? So you can write out the whole table. I just happen to have those notes in hand from day 8's notes to do that instead of having to write that table all the way out again. All right? And then we got into binomial theorem. And that's when we use Pascal's triangle to be able to expand and to be able to find a certain term and all of that good stuff, okay? And I'm giving you the Pascal's triangle. I'm going to also give it to you on the test, all right? So we want to expand x plus y to the 3rd power. So 3rd power means I go to the 3rd row, all right? So that's 1, 3, 3, 1. And notice I'm expanding these out again for a reason, so I can put my x's and my y's in there. And remember, the first part of my binomial starts at my largest exponent, x to the 3rd, and it gets smaller. So x squared, x to the 1st, and then x to the 0. And then my y starts out small and gets bigger. So y to the 0, y to the 1st, y to the 2nd, y to the 3rd. All right? And so anything to the 0 power or the 1 in front can go away. So that's just x to the 3rd. plus 3x squared y. And again, you don't have to write the exponent of 1, it's understood. Plus 3xy squared. And again, 1 and x to the 0, we don't have to write that, and that just becomes plus y to the third. And that is our answer. All right, so then we have example of a triangle, and you want to expand a minus 2 to the fourth. Okay, so this one's just a little bit different because we have a number in our binomial. All right, so we go to the fourth row. That's 1, 4, 6, 4, 1. All right, and again, my first one is going to start out big and go smaller. So a to the fourth, a to the third, a squared, a to the first, and then a to the 0. Then we've got negative 2, and it's going to start out small and get bigger. So we have negative 2 to the 0, negative 2 to the first. I didn't expand my stuff out far enough. Negative 2 to the second, negative 2 to the third, and then negative 2 to the fourth. All right, so again, anything to the 0 power and that 1 out front goes away, so that gives me a to the fourth. All right, negative 2 to the first is still negative 2, so I'm going to do 4a to the third times negative 2, and those two numbers are going to multiply to give me negative 8a cubed. All right, and then for my next one, negative 2 squared is positive 4, so that becomes 6a squared times positive 4. And again, we multiply those together to give me plus 24a squared. And then the next one, I have 4a to the first, and then negative 2 to the third is a negative 8. Yep, negative 8. And so 4 times negative 8 is negative 32a. And then our 1 and our a cancel out, and then we got negative 2 to the fourth, which is positive 16. And that is our expanded way out. All right, that negative 2 to the fourth is what gives me that positive 16 there. All right. And then we talked about finding a certain term in the equation. And so the way we did that was we had n factorial over r factorial times n minus r. And remember that r value, the n value is my largest exponent. The r value is one less than the term we're looking for. Times x to the n minus r times y to the r power. And x and y is just the first and second term that are in the binomial that we're multiplying out or finding a certain term for. So here we want to find the fifth term of a plus 2b to the fifth. All right, so that means n is 5, so that's 5 factorial, over, and then my fifth term tells me that r is going to be 4, because it's one less than that, times 5 minus 4 factorial. And then it's x to the n minus r, or in this case, a to the 5 minus 4. And then we have plus 2b to the r power, which is to the fourth power. All right, so then we start simplifying, okay? So we've got 5 factorial divided by 4 factorial times 1 factorial. Oops. Because 5 minus 4 gives me that 1, which gives me 5. A to the first, because 5 minus 4 is 1. Now here, remember, that's when you have to expand and put or distribute the 4 to both the 2 and the b. So 2 to the fourth power is 16, so that becomes times 16 b to the fourth power. So what you have to do is take these two numbers, 5 times 16, and multiply them together to give me 80 a b to the fourth. So that is what my fifth term would be in that equation. All right, so then let's do that again for the third term of x minus 5 to the third. All right, so again, my largest exponent there is 3, so that's 3 factorial, and we're looking for the third term, so that means that's going to be 2 factorial because it's 1 less than that, times 3 minus 2 factorial times my x to the 3 minus 2 times -5, because that's what my y value is in this case, to the second power. All right, so 3 factorial divided by 2 factorial times 1 factorial gives me 3x to the first, because 3 minus 2 is 1, times -5 squared, which is positive 25. So we multiply those two numbers together to give me 75x. So that would be my third term of that equation. All right, and then the last 2 problems is talking about expected value, which was on the very last part of the notes. And so we have 25. It says, in a game, you roll a die. If you get a 1, you win $5. So again, remember that's $5 if you get a 1. And so a 1 is 1 out of 6 chances. If you roll a 4, you win $15. So that's $15. And if you roll a 4, that's only 1 out of 6 chances again. If you roll a 2 or a 6, so that's 2 out of 6 chances, you lose $10. So minus 10 or negative 10. If you roll a 3 or a 5, you win nothing. So that's plus 0, 2 out of 6, because 3 or 5 is 2 out of 6 possibilities. What is the expected value or one roll, that's supposed to say on one roll of the die. So let's do that. 5 times 1, 6, plus 15 times 1, 6, minus 10 times 2, 6, plus 0 times 2, 6, which gives me 0, which means that this is a fair game. So it's possible that you could do anything from 0 to gain money to lose money, because remember we said if you hit 0, the game is evenly fair on all ways. All right? But you are most likely to just come out even and playing the game. All right, number 26, you pay $10 to play the following game of chance. You have a bag containing 12 balls. 5 are red, so 5 out of 12 balls are red. You have 3 that are green, so 3 out of 12 balls are green. And then the rest are yellow, and so that means that I have 4 out of 12 left over that are yellow. All right, if you are to draw 1 ball from the bag, you will win $14 if you draw a red ball. Now, again, we talked about this earlier. You pay $10 to play, so that means you're actually only gaining $4 because I've already lost 10. So if you draw a red ball, that's $4. You'll win $12 if you draw a yellow. So again, if you take away that $10, that's 2. And then obviously it doesn't say anything about the green, so that's plus 0 out of 12. And it says, how much do you expect to win or lose if you play the game 100 times? So 4 times 5 out of 12, plus 0 times 3 out of 12, plus 2 times 4 out of 12, which gives us, oh wait, nope, I almost forgot it again, 10 minus 10, because if we get a green, we lose $10 because we didn't gain any money at all. So I did that in the last time I did this problem. So 4 times 5 out of 12, minus 10 times 3 out of 12, my bad. 3 out of 12. Oops. Oh, shoot. 4 times 5 out of 12, minus 10 times 3 out of 12, plus 2 times 4 out of 12. There we go. Gives me a total of negative 16 cents. And if we play that game 100 times, that means we're going to lose $16.66 or 67 cents. That's how much money we'll lose if we play the game 100 times. All right. If you have any questions or comments, please feel free to message me on Remind, or comment on the actual video, or comment on the post in Google Classroom. I will gladly answer as much as I can, as quickly as I can. All right. Bye. I miss you guys.